All right, 8.4, lengths of curves. Not too bad a lesson. How do we find length of a curve? The proof of it's actually somewhat complicated using Pythagorean theorem. You've got a curve, and we say, let's take a chunk of that curve, and let's have a delta x and a delta y. Well, this distance here is the square root delta x squared, delta y squared. Notice that this becomes infinitesimally small. We get a tiny little piece. If we add them all up, and I'll throw a delta x and a delta x here, just because I'm going to need them, we get something like this. All right, well, let's take this delta x and throw it inside. In order to throw it inside, we have to square it. So delta x squared over delta x squared. Really don't need this massive long thing here, plus delta y squared over delta x squared. I took this one here, threw it back here, and we do that calculus thing where we say as the delta x goes to 0, this goes to ab 1 plus dy dx squared dx. And that's our formula. That's how we do it. The length here, L, of course, delta x squared plus delta y squared, which I've already done, but thought I'd just write it out, make it explicit. Do you care? No, you don't. You just care about using your formulas. So length of a smooth curve. That seems like an important word. If it begins at some a comma c value and goes to some b comma d, where a is less than b and c, yeah, whatever, man, then the length of the curve is right here. So we can do it on the x-plane, do it on the y-plane. Let's apply. All right, what's the length of the curve y equals sin x from 0 to 2 pi? If I took a wet spaghetti noodle and ran it on there, how long would it be? Well, length equals the integral 0 to 2 pi, square root of 1. And people mess this up. It's not hard. It's easy to mess up. But what's the derivative of sine? Cosine. 1 plus cosine squared x with respect to x. Oh no, how do I do this? Well, this is where I use a calculator. So let's put it up there. Math 9 from 0 to 2 pi second square root 1 plus dy dx, in this case cosine. Get that funky thing where we put the squared out there and parentheses all matched up with respect to x. Blasted out, we get 7.640. No units given. Leave it. Otherwise, linear units. Feet, miles, inches, that sort of thing. Pretty straightforward. Wait a minute, why don't we do this by hand? Because we can't. We could. No, actually we can't. It'd be a bit of a hassle. All right, find the exact length of the curve, blah, 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 from 0 to 1. Well, now we'll do it right. Here, I just kind of slapped it together. Let's find the derivative. 3/2 goes out front. We end up with, remember, we only care about the x, and we subtract 1, which is weird because we've been doing all this integration and stuff, and now we've got to kind of retrain our brains, think about derivatives. Minus 1 vanishes, so we get 2 root 2 x to the 1/2. And the length will be integral from 0 to 1, square root of 1 plus 2 root 2 x to the 1/2 squared with respect to x. Maybe we can do this one. 0 to 1, 1 plus 2 squared is 4, root 2 squared is 2, 4 times 2 is 8, x. Can we integrate that? I don't know, it feels like a u substitution thing. Oh no, I forgot all about this. Man, it's almost like I planned to do this so that you'd have a chance to practice. Nah, I'm sure that's just a coincidence. du over 8. So this becomes, oh, we got to change our limits too. U of 0, plug in 0, we get 1. U of 1, we get 9. So integral from 1 to 9. This becomes du over 8. I put it out front. And this is u to the 1/2. Yep. Integral 1/8, 2/3 u to the 3/2. 1 to 9. Square root of 9 is 3. 3 to the 3rd is 27. 3 is 9 times 2 is 18. 1/8. I'm going to run out of space. What the heck? 1/8. 18. 1 minus 2/3. 3 times 18, 54. Minus 2, 52. Over 24, which is 26 over 12, which is 13 over 6. Wow, that actually worked. I'm shocked. 13 over 6. Again, no units given, so we don't give any back. I don't believe you, Mr. T. I think you're full of it. I don't blame you. So let's go in here. Let's see how fast I can delete this. That works. And parentheses, 2 square root of 2 x square root of x parentheses squared. It's a decent chance I mess this up. Let's see how we do. From 0 to 1. Wow. 13 divided by 6. I would have bet money against that happening. Cool. All right. Now, what was that word on the previous page? I believe it was smooth. Meaning continuous and differentiable, no cosorners. But notice only on the interval. So if this thing is some weird curve, but we only care about a part that is smooth, we're good to go. And on the flip side, if it's not, we just break it into 2 pieces and kind of ignore the middle. On the interval we're using, that's all we care about. So for example, a vertical tangent or cusp or corner, whatever, if you graph this, you'll see it does this. And that's a vertical tangent in the middle. So it wants to know what's going on from -8 to 8. And it's y equals x to the 3rd. So no problem. Y equals x to the 1/3. Hey, I got a better idea. Rather than break it into 2, which I could do, how about we do this? Oh, that's really cool. Of course, this might hurt some people's brains. So instead of dy dx, we do dx dy. Oh, that's just so cool. 3y squared dy dy cancels. All right, length equals, well, what are the y? Oh, wasn't that nice of them? these people, they just look out for us sometimes. Square root of 1 plus 3y squared dy. That is so weird. Calculator. Length equals. Nah, I think I'll do my own. Keep doing that. Math 9, -2 to 2. And actually, I like putting this in because it's a dummy variable. People are like, well, how do I put in y? You don't need y. It doesn't really care. $8.340. I think I did something wrong. Yep, forgot to square it. Yeah, well, consider that practice. That's right, and then square it again. 17.261. Linear units which weren't given. Nice, glad I made that mistake. Cool. Find the length of the curve, y equals x squared minus 4x. Graph it. It does this kind of weird little nice smooth curve, poink, little corner right there. So we just have to do it twice. Length equals from -4 to 0. Root of 1 plus, over here, this is going to be x squared plus 4x minus 4 because it's negative of what it really is. Over here, it's going to be x squared minus 4x minus x. Where did I get this 4 from? Weird. In other words, x squared plus 3x. Over here, x squared minus 5x. Oh boy, these problems, they make you work hard. Derivative 2x plus 3. Don't forget the squared like I did. Integral 0 to 4. 1 plus x squared, no. 2x minus 5 squared dx. Blast it all out. 19.560, I think. You know what? Let's do it from scratch with this equation and see what we get. Math 9, -4 to 4. So square root 1 plus. Now, wait a minute, I got to put the derivative in there. Yeah, fine. Math. Where'd it go? Deriv. So d dx of x squared minus 4. Look at this mess, huh? Well, this is why if you can do math, get paid the big bucks. Well, not the math teacher, but you get the idea. With respect to x, that's squared. With respect to x. This might crash my calculator. I'd love to see that personally. Give me exactly 16. Interesting. Didn't quite get it right. That's squared, but I need another set of parentheses here. And I don't need these. So whatever that derivative is, squared. There we go. Sorry, I didn't put that on there. Still thinking about it. 19.5. Oof, not even close. 556. Wow. Okay, anyway. As always, math is a big pain. Challenging problems, make it work. But then when you get to the AP question, it's like, wait a minute, that's not hard at all. So from x equals 1 to 2, 1 to 2, 1 to 2, 1 to 2. Darn, I thought I could get one. Y equals ln of x, therefore dy dx equals 1 over x. Therefore, it's square root by 1 plus that squared, 1x squared. Good thing I crossed that out. I would have been confused. That's it. Some good math. Have fun.